So in this video, I'll instruct you on how to manually compute a T-statistic. This is very similar to the procedure that you've used for calculating a z-score for a sample mean. Basically, the only difference is that we are swapping out sigma for s. So it's probably a good idea to kind of organize these different parts of the formula and label each one. So we have an x bar, we have mu, we have s, our sample standard deviation, and then we have, maybe let's just do the square root of n. Okay. If we compute, so x bar is the sample mean or the sample average, and these are a made-up sample of, say, stress score ratings, and we're going to use the average formula, select those, and that's our x bar. Now our mu is going to be not something that we compute here, but that's just something that is claimed, so we get that from the null hypothesis, or if we happen to already know, if it's a known mean for the population, as is often the case for things like IQ scores, then we use that. Let's say that the claimed mean for this population, or what we want to test, is a claimed mean of 8. Okay, and then the s, this is the main thing that differs. We're going to use stdev.s, and we're going to compute the standard deviation for just this sample. Okay, so that's the standard deviation of just these numbers in the sample. If you're doing a t-test, when you've seen z-scores, problems related to z-scores in the past, I will always give you the standard deviation, or I'll say, consider these numbers here to be your population of interest, so you can calculate the sigma from all of those numbers rather than from the sample. When you're doing a t-statistic, you don't know sigma, and so you're just going to use s. And then we have, this is a handy way to count these up, you can just kind of select them, and then you can see right here at the bottom, count equals 10. So the square root of n is going to be sqrt formula, and then 10. Okay, so now you may recall when we compute a z-score for a sample mean, we compute the standard error, which is this value here in the denominator, and that's going to be same formula as before, just a s instead of sigma, so that's s divided by the square root of n, so there's our standard error. And then the difference on the top is going to be our x bar minus, mu. Okay? And this, when we construct a null hypothesis for this particular test, you would see something like h naught colon mu equals 8. Okay? So that's what's the claim that we're trying to test. Okay, so there's the difference, and then our actual t-statistic then is the grand finale, the difference on top divided by the standard error below, and so our t-statistic is 4.07.